Good day and welcome to FDM, the channel dedicated to Ferra data models. I want to show you the impact of varying the contact rate today. So what I did was to loop through various averages of the Pareto distribution. I'm going to draw random values from the Pareto distribution and use that as the contact rate to drive the simulation. So here, for example, I've got the baseline, which is the familiar one, 100 million population size, contact rate of 1, and the new infections look like this. This is the baseline. In the middle of the year, we see 20 million per week, and then it dies off rapidly. Okay, so I created one where I used a contact rate of 1, then a contact rate of 2, a contact rate of 3, and so on, up until 10. What I also did was to use a Pareto distribution to produce random numbers. And the random numbers will have an average of 1, but instead of using a fixed contact rate, I would use these random contact rates. And then this is the outcome, for example, of 200 simulations where I draw random values for the contact rate from the Pareto distribution with average 1. Okay, so I did that for a Pareto distribution with average at 1, with average at 2, at 3, and so on up until 10. So let's look, for example, at the 5 one. There's the 5 one, and here you can see the outcome. The outcome of 200 scenarios. I would also calculate the average and the median of these 200 outcomes. Okay, so let's look at the results. Just find it. So here's the different contact rates, and there you can see for the first scenario I specified an average of 1. There's the average of the 200 simulations, and for the next one an average of 2. There's the outcome for each of the weeks, and so on. So for example, this one is for the second to last one where the average is 9. That one is the average of 10. So that one, you can see it varies wildly, but its average should be around 10. The averages behave very erratically, but here if you look at the medians, these are the medians. You can see they behave very well. Medians are quite stable as we would expect, but the averages are very wild because this is a fat-tailed distribution, right? So there we have the 1 median, the 2 median, and so on. Okay, so let's use these contact rates then to drive simulations, and let's look at the outcome of that. Here's the number of new infections per week in the simulations where there's no variation. The contact rate is fixed, doesn't come from a random distribution, and here the contact rate is 1, there the contact rate is 2, there the contact rate is 3, and so on. And you can see as the contact rate increases, how this thing dies out quicker. Actually, to some extent, this improves. This is maybe a better scenario than this one because it's over quicker. That's a contact rate of 6, right? So at a contact rate of 6, this thing dies out so quickly because there's simply nobody else to infect. But these are the outcomes for fixed contact rates, no variability. So let's start checking those contact rates and see what happens. Okay, so let's look at the average outcomes of the alternatives. Here's the first one. And here you can see, if the contact rate is 1 on average, but it varies using a Pareto around 1, this thing hardly moves. Okay, this is a percentage of the total population. So there you see it is extremely flat. If we up that to 2, then the thing increases. We see something like that, but it is miles away from the baseline outcome. It looks a lot better, right? If we go to 3, contact rate of 3 on average, but varies around 3, then we see something that might be approaching the baseline. I mean, the baseline sort of peaks here, but the baseline peaks at 40 million, or is it 20 million? I think at 20 million, if I'm not mistaken. So the moment you start varying the contact rate, the situation improves dramatically. Right? So I'm not clamping down on the contact rate. Of course, contact rate is going to go down rapidly now, and the government wants to have a contact rate of 0 really with a lockdown. So we should have something extremely flat, and if the contact rate is absolute 0, then that would be the end of it. The fear, of course, is that it's not absolute 0 and it pops out later. Be that as it may, if the contact rate is reduced, it will improve it, and if the contact rate varies, as it should in real life, the situation changes dramatically from the baseline. Well, that's it. See you next time. Bye-bye.